Good afternoon, everyone. So everyone can hear me, even the backside? Yeah, cool. So this is too high, so I will present here. So I can press the desired button on the car door without looking at it. First, I'm gonna reaching out my arm to the rough direction, utilizing the proprioception, and then I'm gonna refine my fingertip with the tactile exploration. Similarly, we may interact with the VR menus without looking at it by rapid roll pointing through the proprioception, and then fine-grained adjustment with the tactile exploration. We propose Pro-Tact, which is eyes-free pointing technique for interacting with the VR menus on the out-of-view space. We envision a future where the VR menus are placed on the out-of-view area, and then users can interact with them without looking at it. This is Yeonsu Kim, here to introduce Pro-Tact with our wonderful collaborators Jisoo Im, Kyungwan Kim, Yohan Yoon, and Professor Gyeok Lee. And let's begin. So currently, VR menus occupy the user's field of view, which blocks the main contents and harms immersion. However, what if we place the menus on the outside of the field of view and then make them interactable without looking at it by utilizing rapid roll pointing with the proprioception, and then fine-grained adjustment utilizing the tactile exploration. So here's the concept. We are going to maintain our user's field of view just for our main contents and place the menus on the out-of-view space, and then make them interactable without looking by proprioception and tactile exploration. So we're going to first divide the out-of-view space into the proprio zone, which are the zones that can be distinguishable only with the proprioception. This proprio zone has two requirements. First, it should be large enough for people to select it accurately without looking at it, only with the proprioception, while the number of the proprio zone should be large enough to fulfill the multiple menu items. And then we're going to provide a tactile feedback with the trigger buttons of the VR controller for the tactile exploration. Then the first question arises. How should we design the proprio zone? So what should be the adequate size and number of the proprio zone? And then is there any discomfort areas to point it without looking at it? So we run the study 1. We explore the performance and user experience of eyes-free raycasting on out-of-view targets. So we made a celestial sphere which centered on the user and then has a 100 meters the radius. And then in the random location, the target appears on the surface of this celestial sphere, and then the participant have to ray point it without looking, only relying on the proprioception. We measure the error magnitude, which is the magnitude between the target and the actual selection area, and then the comfortness. So there was significant differences in the error magnitude, whether the target is on the front side or the back side of the user. So we divide into the 3 regions and then plot the CDF plot of the error magnitude. And then we utilize the 90% percentile error magnitude to set a minimum size of the proprio zones. And then we collected, is there any discomfort areas from the participant? And then the comments indicated that it is difficult to select the targets directly behind the users due to the arms, due to the arm. Yeah, so sorry. And then, so we are gonna exclude the backside, and then we are gonna utilize the remaining out-of-view space as a proprio zones. And as a result, we designed 6 proprio zones, and then which has a 60 degrees, size of the 60 degrees. And then the next question should be, how should we design the tactile exploration? So to mimic the tactile exploration, how we usually do in a real world, we put the 5x6 pin array display on the VR controller's trigger button so that it can provide you the tactile feedback on your fingertip. And then, through the exploration, we found out that providing the static tacton, which indicates the location of each menu item, was effective. Thus, we chose this design for the Pro-Tact. So we designed a Pro-Tact, and we believe that Pro-Tact enables fast and precise eyes-free out-of-view menu selection. However, does it? So we run study 2. We evaluate Pro-Tact compared to the eyes engaged and eyes free method as a baseline. So what means eyes engaged is that what we usually do currently. So we are going to select the menu item with looking at it, and then eyes free is we are going to select the menu item without looking at it, only relying on the proprioception. So on the proprio zones, target menu item appears, and then the participants have to select it. We measure the accuracy, selection time, and the usability responses. This is the summary of the result. So Pro-Tact shows high accuracy, however, longer selection time, however, less sickness. So we can conclude that Pro-Tact excels on tasks where there's no time constraint on the selection, and also, or the repetitive selection is required. So what are representative scenarios that the applications of out-of-view menu and then Pro-Tact? Out-of-view menu excel on the application which requires wide workspace or application which requires immersion, since it does not occupy the user's field of view. As a result, we come up with two representative applications. First one is tool selection task on productivity applications, and then the weapon selection task on the game applications. And we implemented it. So this is the 3D drawing application we built. You can see that the participant is selecting the menu items without looking at it, focusing on the main task. So here, users can fully utilize the field of view area for the drawing space because we placed the tools on the out of view region. And the second application is the shooting game. So we put the weapon item menus on the out of view space, and then you can see that the players keep their eyes on the enemy, fully immersed in the game, so while repetitively switching weapons without looking at it. Okay, so let's assume Pro-Tact actually apply to the real applications. Then, well, do users actually prefer interacting with menus without looking at it? So we don't know. So even though we designed the out-of-view menus can be interactable without looking at it, maybe users just prefer just looking at it because it's more usual thing they do. So we want to observe whether users voluntarily utilize eyes-free menu interaction in actual applications and the reasons behind it. So we run the study 3. We provide the applications to the participant and then ask them to utilize applications as they want. Whether to select menu items with looking at it or without looking at it are free to them. And then we observe the proportion of eyes-free menu interaction, change it with the longer application use. And then this is the result. The proportion of eyes-free menu selection gradually increases with the application use. And then we asked the participant the reason behind it, and then they said that to relieve discomfort and to concentrate on the main task, they prefer to use the menu item without looking at it. So we designed the Pro-Tact, and then we showed that Pro-Tact enables accurate and less sickness out-of-view menu selection. However, this concept is not just limited to the simple menu item selection, but it can be far extended to the other eyes-free VR interactions. To discuss, please contact me, and also I'm seeking the internship opportunities. I'm looking for a wonderful collaboration. Thank you.
Yeah, amazing works. So my question is, so how long the user need to stabilize there in order for the system to identify you are choosing that? Because like when you talk about proprioception, there's a temporal dimension. Is that you can do this, and I know like I can close eye and I do this, and I know I have done this instead of like doing this. So it's like there's a temporal dimension that like how long you can you need to stabilize to I'm praying there, or like do you think about utilizing that temporal dimension of the proprioception? Yeah.
Oh, so I think this result is maybe the answer to your question. So actually, when we observe it, so the participant can first for the proprioception, it just not took much time. However, for the tactile exploration, it took a long time. So that in overall, the selection time for each menu item was 3.3 seconds. Yeah. Thank you.
Hi. Thanks for the amazing presentation. I'm Nandi from UCalgary, and I wonder if you have run any pilot study to decide on the granularity of the tactile feedback?
Oh,
Because right now it's 3 times 3, right? Whether you have try any even finer grain of the tactile.
You mean the tactile display?
Yeah, yeah.
Oh, so actually we did not run the experiment. However, this tactile display, this pin array display is the distance between the pins is like 1.5 millimeters, which is really similar to the how to precise our fingertip can distinguish. So I think it's does it answer to your question?
Yeah. Okay, and one more question if time allows. I wonder what are the main reasons for inaccurate selection for the proprioception one, and I wonder whether they can be combined to increase the accuracy potentially.
Oh yeah, so there are two main points. One point is that so the tactile feedback we provide is it will be the same for each proprietary zones, so that we cannot distinguish when we when there is error on the proprioception, only with the tactile exploration maybe users might not refine the zone error. So that's the one. And also there was the error of the tactile perception. Yeah, so I think there is the room for improvement for the tactile feedback design.
Okay, thank you very much.
Thank you.
Thank you. Thanks for the great talk, Mokari from Princeton University. So I was wondering, you've said that you can also transfer this to other VR applications. I was wondering if you've any perspective on transferring this out of VR into augmented reality, or even any interaction without a headset, because it seems to me like you could even control Spotify with this kind of interaction outside of your field of view, and maybe have fine-grained interactions like playback 5 seconds or 20 seconds. So is there any thoughts on getting this outside of the VR world?
Oh, so you mean that what kind of further application that further research can be done? Yeah, so there are 3-dimension axis. First, we can improve the tactile feedback. So currently, tactile feedback only provides the location of the menu item. However, we can make it to provide information such as signifier, feedback, and feed forward. And also, and then another axis is that we can improve. Currently, we are just utilizing this for pointing and selecting. However, we can utilize such as dragging. So maybe the menus are here, and then we can drag the menus in front of you, and then drag back again, like it's a drawer. That kind of interactions also can possible. And another one is that, so currently we are utilizing the controller for providing the tactile feedback. However, so the concept is not only on the controller, but we can also make it on the wearable type to give the tactile feedback. So it also can be utilized on the on-body interaction, so that when we on-body interaction, we can sense the tactile feedback. However, we need a more precise feedback to select these precise zones. Then also, this also can be utilized not only the menus but also the on-body interactions and such that.
Thanks a lot.
Yeah, thank you.
Thank you. Hi, thank you for your talk. So I was just wondering, so you are basically using tactile exploration to explore these menus that you move from out of the field of view of the user. But if you can use tactile exploration, why do you actually need the menu? Like the visualization of the menu. Could you just use tactile and be able to even use like that outer space for other things?
Yeah, so actually the thing I really like about this work is that we place the menus where we can refer to it every time. I mean, so when we totally remove these menus, then we have to memorize all the comments. However, because we place the menus which can be referred at any time the user wants, the users do not have to memorize all the menus. However, as you mentioned, we can utilize this space not for showing the menus, but also like in displaying any other information. Yeah, that kind of improvements also can be possible.
Thank you.
Thank you.